Okay, so today we're taking a look at 2015 and the free response questions from 2015, and we are on number 3. So for number 3, there's no calculator allowed. Looks like we're given some velocity values in a table, and it says Joanna jogs along a straight path for t between 0 and 40. Joanna's velocity is given by differentiable function v. Selected values of v of t, where t is measured in minutes and v of t is measured in meters per minute, are given in the table above. For part A, use the data in the table to estimate the value of v prime of 16. Do you know how to estimate the derivative? Okay, so for part A, to estimate v prime of 16, we need to locate 16 on the table. 16 is between 12 and 20. So what we're going to do is we're going to find the slope of those two values, okay, or in between those two values there. So we'll take v of 20 minus v of 12 over 20 minus 12. 20 minus 12 is 8. The velocity at 20 is 240. The velocity at 12 is 200. So 240 minus 200 would be 40 over 8, which is just 5. The v of t, the numerator, is measured in meters per minute, and t, the denominator, was measured in minutes, so the units on this would be meters per minute per minute. Okay? Or you could say per minute squared, right? So the numerator here was meters per minute, and the denominator was minute. So when I put those together, I'd get meters per minute per minute. Okay? Part B, using correct units, explain the meaning of the definite integral 0 to 40, absolute value v of t in the context of this problem. Do you know what that means? So let's start there and let's figure out what that means. So for part B, if I take the integral of the absolute value of velocity, that is going to be the total distance that Joanna jogs from t equals 0 to t equal 40. And I would actually probably want to put the units that she's jogging in, right? So I would say the total distance in meters. Joanna jogs from t equals 0 to t equals 40 minutes. Okay? Just to be extra thorough, making sure you include all units that were originally given in the problem. So the integral of the absolute value of velocity is the total distance in meters Joanna jogs from t equals 0 to t equals 40 minutes. Okay? If we continue, it says approximate the value of the integral from 0 to 40 of the absolute value of v of t using a right Riemann sum with 4 sub-intervals indicated in the table. So a right Riemann sum. So if I have the subintervals, right, that says 4 subintervals, so we've got those points, it's pretty easy to identify which 4 subintervals we're going to be using, but this time we're going to be using the values that are on the right. Okay, so between 0 and 12, the value that's on the right would be the 200 here, and between 12 and 20, it would be 240, between 20 and 24, negative 220, and then between 24 and 40, it would be the 150. Okay, so on the first one there, so from 0 to 40, absolute value velocity dt equals, the first one has a width of 12 and a function height of 200, so I would take 12 times 200. Plus, the next one has a width of 8 and a function height of 240, so I would say 8 times 240. Plus, The next one has a width of 4 times negative 220, but this is negative, but because of my integral I have the absolute value, it would make that number positive. So it's going to be 4 times 220 plus, and then the last one here, it's a width of 16 and a height of 150. Okay, so let's go through and add these up. 12 times 200 would be 2400 plus 8 times 24. Let's just do the math over here. 0, 4 times 8 is 32, carry the 3, 16, 19, plus 19, 20, plus 4 times 220 is 880, plus 150 times 16, 0, 0, 3, 6, 9, and then 150. So 2, 4, 0, 0. And then we're going to add all these together. So let's see, 2400, 1920, 880, and 2400. 0, 0. 5, 14, and 8 is 22, 26, 2, 4, 6, 7, so 7,600. Okay, and because it's the total distance that she's traveling, that would be in meters. Okay, so 7,600 meters was the total distance Joanna jogged from t equals 0 to t equals 40. Okay. Part C, Bob is riding his bicycle along the same path. For t between 0 and 10, Bob's velocity is modeled by b of t equals, whoops, go away. B of t equals t cubed minus 6t squared plus 300, where t is measured in minutes and b of t is measured in meters per minute. Find Bob's acceleration at time t equal 5. So if I'm given velocity, how do you find acceleration? So for this one, b of t is equal to t cubed minus 6t squared plus 300. So if I'm finding acceleration, we just take the derivative of velocity, 3t squared minus 12t. And then it says to find the acceleration at t equal 5. So we're going to plug in 5. So 3 times 5 squared minus 12 times 5. 5 squared is 25 times 3 is 75 minus 60, so this would be 15. And t is measured in minutes, b of t is measured in meters per minute, so when I take the derivative with respect to time, it will be meters per minute per minute. So this would be 15 meters per minute per minute. Okay? And then in part D, based on the model B from part C, find Bob's average velocity during the interval 0 to 10. Okay, so average velocity. Think of this as the average value of your velocity. So how do you find an average value? Okay, do you remember how to find an average value? So on part D, average value is the integral, right, 0 to 10 of b of t divided by the interval. Okay. So integral over interval is average value. So let's go ahead and plug in the function. The function here being t cubed minus 6t squared plus 300. All right. What is the antiderivative of this function, right? Whenever we see an integral, we want to think of area under the curve and antiderivative. So I've got my function, I've got an integral, I need to find the antiderivative. So to find the antiderivative, we add 1 to the power, divide by the new power, minus add 1 to the power, divide by the new power, plus add a variable. Okay, and we're going to evaluate this from 0 to 10, and then multiply by 1/10. Let's plug in 10. 1 over 10, 1/4 times 10 to the 4th minus 2 times 10 cubed plus 300 times 10 minus, when I plug in 0 for all of that, since they're all just variables, I would just get 0. Okay, since it's a polynomial, when you plug in 0, you're going to get 0. Okay, so let's keep simplifying this. 1/10 times 10 to the 4th would be 1, 1, 2, 3, 4. Minus 10 cubed. So 10 cubed would have 3 zeros and then a 2 plus 3, 1, 2, 3. Okay, and then we're going to be needing to simplify this further. So 1/10. 10,000 divided by 4 would be 2,500. So then negative 2,000 plus 3,000 would just be plus 1,000. And then 3500. And then take off a 0, right? So 350. And so because this is an average velocity, remember velocity is measured in meters per minute. Okay? Okay, let's talk about points. For points on this one, you are going to get, on part A, 1 point for your approximation. So as long as you got 5, you got your point. Okay? On part B, it's worth 3 points. 1 point for correctly interpreting the integral, 1 point for setting up the right Riemann sum, and 1 point for getting your final answer. 1 point for getting your approximation. On part C, you're going to get 2 points for taking the, 1 point, I'm sorry, 1 point for the derivative, and then 1 point for your answer. And then in part D, you're going to get 1 point for setting up the integral, 1 point for your antiderivative, and then 1 point for the answer. Okay, so there's your 9 points. Not too bad. All right, let me know if you have any questions.